get Sam Limbaugh from the Nature Conservancy up, and his talk's titled "How to Train Your Dragon: Drones and Dragon Eggs." And if it's not titled that, it should be.
Hey, thanks, Jason. Let me figure out the technology here. All right. All right, how about that? Is that good, Jason?
I see Zabik.
All right, very good. So my talk today will be about integrating drones into fire operations, as indicated by my title. And not specifically dragons, but that sounds kind of fun. Maybe we should paint ours to look like that. So we started messing around with drones a handful of years ago with just some basic surveillance and just thinking about how we could integrate them to do reconnaissance work and patrol fire lines and that sort of thing. And then along came a new company out of Nebraska, some really awesome engineers that have done a bunch of grassland work out there. And they built this thing called the Ignis, which is a PSD, or a plastic sphere dispenser that you hang from the bottom of a drone. That's that in the top right picture there. That could allow you to actually do aerial ignition from the drone. So our interest was piqued, and we jumped on for the ride. So I was going to tell you this story. Here's a picture of the drone hovering up above one of our pine savannas in southeastern Virginia. We were interested in this new technology because we are constantly facing what I think is often the number one limiter for getting as much prescribed fire done as possible, which is capacity, whether it's people or equipment or money or time or whatever it is. We thought, hey, if we can get this drone to do some of the work that some of our folks are doing on the ground, internal ignition specifically, and patrol, then maybe we can reduce the amount of people we need on the fire line, and therefore we can burn more acres because we can spread them a little thinner or whatever. So some of that turns out to be true, and some of it turned out not to be true. I'm still super happy with the program, but we learned a lot about, we have learned a lot over the last 2 years on how this works and what it actually does for us. So here's why we invested. The drone with the aerial ignition platform on it can reduce your internal ignition time, which of course reduces your exposure to hazards, typical hazards, right? Ticks, stump holes, smoke, getting lost, tripping over stuff, whatever. It can increase your production in terms of sort of just volume of acres, although I'll caution that may not always be true. It can definitely increase your situational awareness of what's happening out on the ground. We have found that to be super valuable, particularly because the camera attached to the drone we have has an infrared lens or sensor, so we can see heat, and you can tune that so you can see, various temperatures of heat, that sort of thing. We thought originally that we could use the drone for planning and monitoring, and that sort of is true. And I say sort of only because we're just now really investing the time and energy required to figure out their true applications for photography. For example, we're trying to stitch photographs together. We fly the drone over a grid over a piece of land, and then you stitch the pictures together and you get a geo-referenced image. So we're playing with that. We've had some misfires and that sort of thing in terms of like the stitching doesn't work together, or the wind was blowing too hard or whatever. So that I would say is emerging rather than a definite. At the end of the day, so after we bought it and jumped in, my perception is that ultimately this is about risk reduction. And if you can, in my opinion, as a fire manager for the Nature Conservancy, if we can reduce the risk, to me, that leads to more capacity, because the risk being reduction of hazards, reduction of fatigue, reduction of staff burnout, just all of those things that come with just day in and day out burning. If you can knock that down, we believe that we're starting to see people can burn more days in a row, because if they're not dragging a torch to the middle of the unit for 12 hours a day, then the next day they're less tired, and that is a little bit less risk. So I think that leads to more fire, which leads in this case to more longleaf pine savanna or Appalachian forest or whatever. Okay, let's talk about what this thing is. The drone itself that we utilize is made by DJI, which is one of the global leaders in drone production or drone manufacturing. The software, what you see on the screen there, is actually made by Drone Amplified, the company I referenced out of Nebraska. And what you see on the map there is a simple burn unit. The yellow perimeter is what's called that's the burn unit itself. The white perimeter just inside of that is the geofence, which is the drone can't fly outside the geofence. It can fly outside the geofence, but it will turn itself off. It won't drop spheres outside the geofence. The little pink and white balls, spheres on the screen, those are literally where the drone has dropped the Dragon eggs. And so if you're not familiar with aerial ignition platforms, there are basically two types of plastic spheres that we use. The smaller of the two are called Dragon eggs, and they're about 5/8, maybe 3/4 of an inch in diameter. The other ones are bigger; they're about 1 inch in diameter. Luckily, this one uses the smaller one so that we can actually carry more spheres in the hopper. Carry about 400, 450, or something like that. So anyway, so that hence the name. They're called Dragon eggs, and somehow or another my presentation was called Drones and Dragon eggs. I think Caliber had something to do with that. But anyway, we think that this system is an excellent ignition and surveillance tool for burns in the range of 50 to 500 acres. The smaller end limit has much to do with the cost of the machining. And if you're burning really small units, it's probably, well, it might not be worth it. It's a pretty hefty investment. So that's sort of the 50 acres, but we burn places smaller than 50 acres for sure. But, if that's what you're burning or smaller, it's not clear to me that this saves you a lot because of how much it actually costs. So the upper end, we sort of tagged at about 500 acres or so. And that has everything to do with FAA restrictions and range limitations of the radio controller. So if we had, if the FAA gave us a little bit more leash and we had a better radio controller, we could fly that thing, on much bigger burns. So in the case of this upper burn, we actually have, and I'll show this in a minute, we've actually combined a drone and a helicopter on the same burn. We've actually done that once. It worked really well. So in some cases, the drone can reduce your staffing needs. So, and I say in some cases, not all cases. And I would say those cases are described as the burns that otherwise would require a lot of internal ignition. So if you're going to have staff that are going to have to drag torches back and forth across the unit all day long, and it's hot and it's brushy or lots of greenbrier or whatever, the drone is exceedingly helpful there and can definitely reduce your staffing needs, because you just don't need those people in there doing that work. The drone can do it for you. So you can either put those people on the perimeter, or you can just cut them out of your staffing needs altogether. It's a super useful photography tool. We get some really cool photos, both infrared and true color. As I mentioned earlier, it is a risk reducer, in my opinion. It does save time. We can ignite burns much faster than you can do by hand. So we can fly, a 100-acre unit in half an hour. Of course, if we have the control line set that way. And it's a lot of fun, I'll have to tell you. Flying the drone and getting it done and integrating that into your operations is definitely fun and part of the appeal for me for sure. Here's what it is not. It's not a helicopter replacement, though there is some overlap. The reason it's not a helicopter replacement is if you're burning large burns over road areas that are hard to get to by foot, it is not the same. While it does have a really cool camera, having spent a lot of time doing helicopter work and having spent a lot of time flying this drone, the view is not the same. So having someone in the air with the ability to talk to the pilot and fly exactly where you want to go and do reconnaissance and surveillance type work, that's you can't do that with a drone. You can come close, but you can't quite do it. And the biggest difference is that the helicopter obviously doesn't have range issues. You can fly that thing for hours, and we can carry 4,000 to 5,000 spheres versus 400 spheres. So the amount of ignition that the helicopter can do compared to the drone is really just not comparable. There is some overlap. The overlap is sort of when the burns get around 500 acres, where you think, well, a helicopter seems really, really expensive for that small of a burn. Although it is, doable, you can fly the burn in some cases if you've got good landing and recovery zones. So again, there's a little bit of overlap there. It doesn't always, I should have put the word always, it doesn't always increase your capacity. And the reason why is because the drone actually requires staff. You can't, you just don't get this robot and it just flies around. You got to have people committed to the drone. So let's say you cut down on 2 or 3 internal igniters. Well, you're going to have 2 people to run the drone program anyway. So that's a sort of 6s in that regard. So I don't know that it really increases your capacity or reduce your staffing needs. I think in some cases it can. All right, well, everybody wants to know, like, how much does this thing cost? It's $50,000. So that's what our program cost us. And that does not include the recurring cost of the Dragon eggs. Those are about $330 or $20 a box of 1,000. So we've actually gotten really good at burning. I've learned a lot about how many spheres you actually need to put on the ground that I intend to take back to doing helicopter work. And you don't need as many as most people think. So anyway, so we've gotten really efficient with using the spheres. So that's not a crazy cost, but it is definitely real. The drone itself, plus extra batteries, is about $10,000 to $12,000. The Ignis, which you see, I don't know if you can see my mouse moving around, in this box here in the back, in this little Pelican box, that's the actual Ignis. That's what, and it's the picture at the top where it says Phil. That's the actual device that Drone Amplified makes that hangs on the bottom of the DJI drone. That device is about $22,000. Pretty expensive, for sure. The camera, which you see in the top of the screen there, we got ours for about $9,000. So super expensive. This is the state-of-the-art camera that has an infrared lens and a true color lens, and you can fly them both. You can run them both at the same time. You can take video and still shots from infrared. And the really cool thing about the infrared camera is you can tune it. So you can actually ask it or tell it to display on your screen various temperature bands. So you can say, for example, the first time we got this drone, let me go back I thought I had a, yeah. So you see the picture in the center, on the bottom center, and it looks like the entire world's on fire. That's because we had the temperature threshold set too low. So you can actually set the color detection, I'm not sure the right word, but you can set the band so that it excludes all temperatures below a certain point, right? So for example, in this particular photo, I remember when we were flying this unit, when we first got the thing, we flew over the road, over the asphalt road adjacent to the burn. It looked like the asphalt road was on fire, right? Because we had the temperature set too low. So, you know, the road was obviously hotter than the surrounding landscape. So it looked like it was on fire in the camera, which of course it was not. So we've since changed that. You can actually tune it to see only the temperature bands that you want, which is really helpful, particularly when you're looking for spot fires or you're trying to look through the smoke to see if you've got anything on the other side of the line. So anyway, really helpful there. We bought a really nice case, which cost us $1,000. It's that blue, big, humongous black and blue box on the right side of the screen. That case is really helpful because you don't have to take the legs off the thing, and it allows us to move from landing zone to landing zone pretty quickly. You got to have a generator because you got to charge batteries. You got to run that generator nearly all day long. We have 4 sets of batteries, and we run through them pretty consistently. Got a little landing pad there. And obviously the spheres are 350 per 1,000. So here's the elephant in the room. DJI has ceased production of that drone. So the drone in the center of the photo there with those 2 white pucks that are kind of in the front, that's the Matrice 600 Pro. DJI has decided they don't want to make that thing anymore, which is a problem for us because that's the drone that is capable of carrying this payload. So we don't know if DJI is going to make a comparable drone. There are some agricultural type drones that they make that might work. There are some companies in the United States that are making some drones, but they're a lot more expensive and a lot bigger, which I see as a benefit and a cost there. There are some supply challenges ahead, and it's not really a supply chain issue. It's literally the companies decided not to make the drone anymore. So that's a big problem for us. And we're not really sure where the future. We think that drone technology on wildland fire is going to stay. We just don't exactly know what it's going to look like. Okay, let's talk about some org chart responsibilities and roles. We consider our drone team as an aviation resource. So not unlike we consider, obviously helicopters on burns as an aviation resource. So we have a pilot. The pilot has to be a FAA Part 107 licensed remote pilot in command. So on the top left, you'll see a UAS pilot's license, and a number of us on the staff have those. It's not that difficult to acquire a FAA pilot's license. But at any rate, you have to learn, take this test, and da-da-da-da-da. The FAA really doesn't want you to fly your drone into other aircraft, which seems pretty reasonable to me. So most of the training that you'll do has everything to do with not running into stuff. Has less to do with actually flying the thing, or has 0 to do with fire. Anyway, so the pilot on the drone team focuses on flight programming, which is just managing the software, safety of the drone, and monitoring where the drone is and what's happening. So they really are focused on the tool itself. You need qualifications in the drone amplified system, and they need to understand typical firing patterns and general fire operations. I don't believe that they have to have a high level of fire qualifications, but what I am not interested in doing is having our pilots that don't really know much about fire and how typical firing patterns work, because that interplay between the firing boss and the staff and the drone pilot is pretty critical. So they do need some fire experience and some training. Tied to the drone, to the pilot is in the foreground, you'll see my colleague Sam, another Sam, who is a qualified NWCG firing boss, although that specifically isn't required. We don't have a rule necessarily for that. But typically, you've got to have somebody who understands what's happening, understands what the crews are out there on the ground doing. So the firing boss is essentially the liaison to the rest of the crew. So they're chatting on the radio, receiving instructions from squad bosses or division soups or burn bosses or whoever else about what types of things that they want done. it is nearly impossible for the pilot to focus on flight programming and safety and also make these decisions about what we're going to do. So we really see those as very separate but complementary roles. So at the Nature Conservancy, we require that person be a firing boss or equivalent. And they need to be pretty familiar with the drone amplified software. Because what ends up happening is that the firing boss will get some instructions from somebody out in the field and say, hey, we'd like for you guys to do this. And then that firing boss has got to look over the shoulder of the pilot, while they're programming it and make sure that it, the mission is going to work for what the field needs. Some training, pilots need significant flight time with small drones. The nice thing about flying this big drone is that it's the same. If you know how to fly a little bitty drone, then you know how to fly this big drone. It doesn't, all the sticks are the same. Everything is the same. The way the drone behaves is a little bit different, but for the most part, flying is exactly the same. Like I said earlier, you've got to have the Part 107 drone license. We took this online training school, which I found it to be very helpful. You also have to take the drone amplified training, which is included with the purchase of the system. That just helps you learn how to use their software and a lot of mechanical stuff of how to debug the thing and repair it, change batteries and all sorts of things like that. We prefer that drone pilot be, because they're on a fire, be, basic fire training, firefighter type 2. Firing boss, we already talked about that. Visual observers. So an added task as required by the FAA is that you know where your drone is all the time. Burning in Virginia with the drone is really difficult because it's really nearly impossible, if not outright impossible, to have your eyeballs on this drone the entire time that it's in the air. But that is a requirement of the FAA. So we've taken a small amount of liberty with our drone program where we have people around the burn, and these are just regular firefighters and squad bosses and PIOs, and anybody else that's out on the burn. And their added task is to be aware of where the drone is and communicate that back to us. So we maintain line of sight that way. There are some gaps in our line of sight coverage. It's impossible to keep 100% all the time. But keeping spatial awareness of where that drone is, both vertically and horizontally, is pretty important. The other thing that the visual observers, aka just the fire crew, have to do is that they need to notify the drone team if they hear or see any other aircraft in the area. This is not something that you would normally have to deal with, but if we have, down in southeastern Virginia, we often have military aircraft flying over. Sometimes they can fly pretty low. So when we see one, we'll typically just pause the drone, figure out where the aircraft is, make sure that we are low enough. We tend to fly really, really low elevation, which is often way lower than any aircraft would fly. So we just make sure we have our spatial awareness so we don't have some sort of mid-air collision, which would be obviously be terrible. So that's something that we place a premium on. The FAA requires Part 107 certified pilots. There's another requirement called the 137 Agriculture Regulation of Hazardous Materials. So the FAA has decided, for better or worse, that dropping spheres, PSDs, the dragon eggs, is an agricultural hazard. And they want to regulate that. So you have to go through a very extensive permitting process in order to get the permission to do this. However, Drone Amplified has worked with the FAA, and they can sub-license you, and that's what they do for us. We have been working with the FAA trying to get our own 137 exemption, and we haven't yet completed that task. So we basically subcontract or we are essentially using Drone Amplified's exemption, and we pay them. It's like $100 a month for us to do that. So visual observers can be anybody, any crew member. They don't need to be drone pilots. Okay, a couple of little just logistical things. You got to have, this is a high precision device. It does not like dirt and grime and grit. We have this space built out in our shop where we can break down the drone, we can clean the whole thing, we can clean the hopper, do all kinds of work, we can program. We've got really good internet. We've got that charger station sitting right there, so we can charge all the batteries, we can service the drone, clean it, all that stuff right there. We found that it was really important to have this dedicated spot. And it turns out that it's been really helpful. You're going to need a generator, one with about 2,200 watts or so. Any of these modern low noise generators like the Honda ones, or we have a Generac, but they're all basically the same. These little quiet generators work really good. You'll need a folding table. You'll need some tarps and some cones to quick setup of a landing area just to keep people from running over the drone with a UTV or whatever. And then you got to have some sort of vehicle, a truck with enough space to hold and transport everything. We have a RAV4, and occasionally we'll use that, but it's a little tight. We have a truck with a camper shell. We put the drone in there, and we can quickly get to where we need to go, set the drone up, and move it to another landing zone mid-burn if we need to. Some planning stuff. I would encourage you to include aviation or drone planning in your burn plans. Just what that really means is thinking about where the landing and recovery zones are. Our specifications is that you have a 30-foot diameter cylinder straight to the sky. The drone can land itself and it can take off by itself, but it does not have obstacle avoidance technology. This one doesn't. So you need a really clear cylinder straight to the sky so they can get up to your elevation, which is typically around 200 to 300 feet above ground level. That landing and recovery zone needs vehicle access. Ideally, it's away from public roads. We're not trying to hide the drone work. What happens every time we have put a landing and recovery zone near a public road, it's not that people are think that well, whatever, we just get a lot of people that stop and want to talk to us and, hey, this is really cool, what are you doing? And it just really is really distracting. So we're not trying to hide the drone. We're literally just trying to be, work in a quiet space. We've run into trouble when we put the drone, downwind of the typical smoke, because if the drone crew is getting smoked out all the time, it just is really difficult to work. So making sure that your landing recovery zone is clear of smoke and other fire operations is pretty important. We have a lot of checklists, like the one up on the top right screen, to make sure that we cover all the things. So there's a million little tasks that you have to do. They're all small, really easy, but if you miss them, then you can run into trouble. I've got two examples of burns. Here's one from my colleague up in Maryland, a guy named Gabe Cahalan. He also has one of these systems. These are two burns. One is 56 acres and one is 10 acres. This is a great burn for the drone. If you measure this out, you can see there on the scale at the bottom, about the furthest distance from, let's say he was going to fly at 0.3. He's no more than about 2,500 feet away from all corners of these burns. So you think like, okay, that's pretty good. We can usually fly up to 25 to 3,000 feet, 2,500 to 3,000 feet away from the landing recovery zone before we start to run into interference or just loss of radio contact. So we tend to stay inside of that. This burn works really well. They did burn this with the drone. They flew it in a grid pattern. Worked great, simple, kept people out of the burn unit. There's a lot of wetlands in here, and it worked out quite well. So this would be very typical. Small burn, easy logistics. You can drive right to the site. Here is a burn. This is on Bowler Mountain. This is a burn that a collaboration between the Forest Service, DWR, TNC. We had some DOF staff there as well, and DCR staff. So this is a big collaborative effort over in Bath County. This is Lake Mumah right there in the blue. This thing is almost 2,000 acres. So we actually considered trying to do this with the drone and realized that we were going to have to move a bunch of times during the day and just thought this is going to be way too complicated. So this is not really drone suitable. We did fly this with a helicopter, which worked great. You can see the red lines. This is where we intended to fly, and that's actually what we did. But here's where the drone was quite useful. If you look at, I don't know if you can see my mouse here, at the sort of, not quite the northern corner, but maybe northeast at drop point 5. That's the top of this ridge running down the primary ridge. We did a bunch of black lining leading up to that burn, and we flew the drone right along from DP5 to DP6 to DP7 all the way down close to DP8. And the drone was able to do all the black lining for us. And that's a really steep territory. It's really, really difficult for people to walk around out there. So in this case, we used the drone for the black lining, a week or after get how many days out ahead of the burn. But we let the drone do the black lining. It reduced the amount of staff that we needed, took a lot of safety concerns right out of it. And then that was it for the drone. We packed the drone away, and during the actual burn, we just flew the helicopter and we didn't have to hold that line. So that's an example of integrating both drone ops and helicopter operations into the same burn. Like I said earlier, we've actually done a burn or so where we had the drone flying and the helicopter flying at the same time. That just requires some specific communication channels, but that's actually not that complicated. So you can do that at the same time if you plan it properly. I think I will finish with a video. I really hope this works. Let me check the chat here real quick. All right, I'll get to those in just a second here. Here's a video. There's no sound. I'll just kind of narrate this. I hope this works. This is at a place called Raccoon Creek Pinelands and Piney Grove Preserve this past March. Here's a picture of Matt and James setting up for the drone. This is all, for the most part, a mixture of loblolly and longleaf pine. There's Bobby, who's the burn boss. The drone's coming in on the right-hand side of the screen. We're flying pretty high elevation right there. This was actually really funny. We were trying to fly one drone to take pictures of the big drone. This is what it looks like from the drones. This is literally the drone flying up above. This is the type of video and still shot you can get. Is this video working? Jason, can you see this okay?
Yeah. Yes, it is working. It's a little jerky, but
yeah,
we're getting it.
Here's our fancy camera. I believe this is at our Piney Grove Preserve. This is typical of PSD ignitions where you have these spots that burn. This is a beautiful little pond adjacent to the preserve. Again, this is some of the video you can get with the drone. Just a beautiful picture. There's the drone in the top left. That's it. It's doing work right now. So it's literally dropping spheres out. And those spheres ignite about 30 to 45 seconds afterwards. This is a really beautiful longleaf restoration site owned by a gentleman named Bill Owens down in southeastern Virginia near Yale. Really cool site. More glamour shots of the drone. So this is really what it looks like. So here's the drone coming in. This is a typical landing zone. There's our little helipad. We've got an engine in the truck. The white vehicle with the truck, that's our pickup truck that we use to put the drone in and carry it. We obviously use it for other things than the drone, but there you go. So you'll see here that we are flying out of a previously burned area, and we are upwind. This was a great launch and recovery site for a couple of reasons. We had a low angle of trees, so we actually got really good range here. And it's out of the smoke. You can drive right to the site. So we were just right up on top of this little bitty hill that had been burned a few days beforehand. And if you're curious, that's longleaf pine. Is that the end of the video? I think that's the end of the video. All right. Oh, there we go. Here's the website for Drone Amplified, and here's my email. I would love to entertain questions. I'm not sure what the timing is here.
Yeah,
how are we doing, Jason?
we're good. We got 5 minutes before break, and I'm sure if we have some more questions beyond that, we can probably keep on rolling. But Devin asked, have you ever had an incident where the geofence didn't line up to the actual on the ground burn unit and dropped eggs where they shouldn't have gone? Is there a protocol in place for goofs like that?
It's almost like Devin has been on all of our burns. I don't know where he would get this idea. Yes, Devin, we have. We have had, we've actually only had that happen once where the GIS but you know what? This wasn't a drone problem. This was a human error. We had, and it's actually at Raccoon Creek. We had, or I think it might've been somewhere else. Anyway, we had a situation where we had a fire line and then we had the swamp adjacent to it. I don't remember exactly the scenario, but when the drone team were drawing the geofence, so you do that on the day of the burn, we basically drew the geofence in the wrong place. We essentially had the geofence external of where, and we basically just misinterpreted the way the map was written. So it really wasn't a technology problem. It was a map issue. It was a GIS error on our part. So we've since have some protocols to fix that. So, but I will tell you that if you're flying drones or helicopters, you should expect that on occasion that balls are gonna go outside the burn unit. There are obviously ways to mitigate that, like draw the geofence way interior. But when you get really good at flying this thing, you'll start to push the limits of where you're going to drop the spheres. This is really no different than having a spot fire on a burn. And the protocol is that we have people on the lines where the drone is working. You just don't fly blind. So the protocol is that we have good patrol, and the drone does not eliminate good patrol. Even though it's got a good camera, you have to have people down there. So the part about, not reducing your workforce, that's definitely part of it. Yeah. And actually Bobby already answered that. I should have read that beforehand.
Aren't accidental drops called training opportunities? Isn't that what you call them?
I think that's right. Yeah. Jason may or may not have any knowledge of that.
Go ahead, Shep.
Just wanted to ask about some perspective relative to the number of acres that you are flying this drone to burn, and then the amortization length of time.
Yeah, great question. So, right. So we've got $50,000 invested in this thing, right? Not to mention the fact that we have to buy spheres at $130 a box. So I think over time, Shep, we used this thing non-stop last year. I mean, gosh, it must have been on 85% of our burns. We used it all the time. And I really do believe that it reduced our risk and our people were not as tired. We had a banner year. All the agencies had, a huge push by fire year last year. I'm not going to tell you that the drone changed that, because I don't think it did, but it definitely helped. There were a lot of reasons we had a really good season last year. I hope we can have that season again this year. The drone is helpful, but it certainly doesn't. So in terms of thinking about that over time, I don't want to compare it to the helicopter because it's a different tool, but we'll spend $5,000 or $6,000 a day flying helicopters. And so it doesn't take long for the drone to earn its keep. It's a fixed cost until it hits the ground and we have to go buy a new one. I think over time it will pay its way. We're certainly in the red currently, no doubt. So that's a sort of loose answer to your question, Shep, but I think it's going to prove over time to be well worth that expense, especially for established programs where burning is like just normal, right? We're just going, right? I think if you're burning very rarely, or I don't think it's worth the money. Yeah.
Go ahead, Fred.
Yeah, I just want to thank you for your presentation, Sam. And just to let folks know, the Department of Forestry does have one of these units as well. You may hear folks that are currently kind of involved in the main program is Rodney Newland and Jim Pugh. but as well as Jason Bronstein. Jason Bronstein is a new addition to our fire staff, and he's going to be kind of becoming the point of contact for our drone program. We are using it on some burns. We're just kind of folding into our per acre cost. We're not adding a special cost right now onto it, since it's more of a training tool for us right now to learn how its capacity. If some of the funding streams that it keeps talking about come true from the federal government, we do have plans to purchase more of these units to get them in our region easier. As Sam alluded to, we have lots of pilots, but we only have a couple that are trained with the Ignis system that we kind of feel comfortable with, that have the capacity to do all the nuts and bolts of it. So yeah, it's a emerging tool. Doesn't replace everything, but I totally support what Sam was saying about its value in reducing the risk of putting some people in some real thick areas or inappropriate areas that you can't really walk through. So no, good presentation. Thanks, Sam.
Yeah, Sam, one thing that I experienced last year, because I was on my first drone burn, is I didn't have any experience talking air to ground. And so that was one thing that we kind of skipped. And I didn't really notice it in your presentation, where you talked kind of a communication plan with some of the less experienced squad bosses and ground crew. I feel like that can get lost sometimes. And so you end up, talking to you like, see the B in Bowler Mountain, that's where I want you to start. And that works, but it's really not the best. So there might be some training opportunities for that down the road.
Yeah, oh, for sure. And I think that you need to scale up that communication based on the complexity of the burn. I certainly remember, I know exactly what you're talking about, Jason, where actually it was literally you and I trying to interpret, like, what does he really want? That sort of thing. The simple burns allow you to just use the same radio frequency that everybody's on. But when it gets bigger and more complicated, or there's a ton of work getting done on the ground that requires a lot of radio chatter, then you gotta have another air to ground channel. Not always, but when we fly helicopters, we almost always have a dedicated air to ground channel. I think it's a little less necessary for the drone, but it can be really helpful. The other thing that is, in my mind, absolutely crucial if you're going to do drone work, is that the people on the ground making decisions about what are happening, and then the drone team, they have to have literally the exact same map. There can be no gaps, no differences. If there's a difference, then the communication will not work. Because Jason could say, hey, do you see the 3,200 foot contour? And like, yeah, I see that. And I am confident that we have the same map, right? So if that's the case, and the nice thing about the software is that you can import this. Almost everybody nowadays is using Avenza PDF maps, or maps made with GIS that are PDFs, and you can import them into Avenza. Well, the drone amplified software also has that ability, uses the same, so we can import the burn unit map. So if Jason's out there asking me to do something, then I can literally program, based on that. Another thing that actually we learned that's really quite helpful, if you've got cell coverage on the burn, if your squad bosses or division soups or whoever's making decisions about what's going to happen on the ground, if there is cell coverage, we will program a mission and snap a picture of it. And just so, like, if Jason's on the other side of the burn, we did this this past fall at a DCR burn over in the Shenandoah Valley. I'm blanking on the name for some reason. And we would literally take a picture. We'd snap a picture of the screen. Hey, Jason, here's the mission. Here's what we want to do. Is this what you want? And you just text the picture. And that person, Jason's like, yeah, that's it. Or no, I don't want you to fly that close to me, or whatever it happens to be. Right. So we, that has actually become a really useful tool. in making sure that that communication is crystal clear. But it doesn't work in Highland County, but it does work to do that.
Yeah, the other thing that was kind of a lesson learned too is it's not an Uber with a drip torch. Once you move to the far side of the burn and you move launching areas, there's no coming back to your division sometimes unless you pick up all the stuff and come back. And so it's a huge asset, but sometimes you do still have to clean things up with the people on the line once you move locations. So
right.
Okay, well, you and I can talk all day, but I think we'll go to break. Any more questions? Excellent presentation. And Ryan said, in burns without cell coverage, a grid overlay on the map. Yeah, it may help, definitely. Grid overlays are key for sure.
And let me close by saying that there are a ton of people on this in this meeting that have contributed substantially to this program. A lot of people, and I don't want to thank them all. I'm not going to name them all, but there really are a lot that have helped make this happen, and it allowed us to really build this tool and expand it. So anyway, thank you all. You know who you are. I appreciate you.